to something like 180 degrees per second. And we'll see if that fixes it, because it may be that we can just have this thing linearly fix it, and your eye isn't going to be too angry with it as long as it snaps to the right thing. The other thing would be if we land on the ground. I don't know, it depends. If we land on the ground, it might be good to just snap to that angle. The other thing that might be good for snapping is if you're going over a certain speed, that we would snap the angle, or the angle exponentially fixes itself. So if we had like a snap this frame, alright, Karakan, you have a good one. So let's see, we should snap if we go from in the air to on the ground. So let's see what an exponential change in angle looks like, as well as snapping when we land. God, movement is just complicated. It's like entire games and simulations are based on just moving crap around. So let's see. We will snap to the angle when we fall. Bam. So let's see, we had basically it's an exponential thing, so let's just set it at to just 1 times the exponent. So our speed is going to be basically the difference between the angles that it wants to turn multiplied by itself. So like 90 degrees times 90 degrees will be much faster then. But probably we'd want like an exponential increase to the speed added to a linear increase to the speed. That way it'll go faster if there's more of a change. But the other thing we could do is we could have your actual movement speed, like your y velocity, also determine how fast this thing actually snaps. That would be another option. So the issue here is this. He's just snapping, snapping, snapping. So the question should be, how exactly should we solve this problem? We could have a damping force. Basically, the more the angle changes, the less it'll let the angle change. Well, we could have the angle change amount is gated by the speed. So basically, the faster you're moving, the more that the angle can change. So if you're just walking, wouldn't do anything. Let's see if this is a consistent problem, something maybe that only happens with the one-way platforms, or if it's something that happens with the one-way and the two-way platforms. Or if it has something to do with if we're sliding. So it looks like it has to do with if we're sliding more than anything else. Everything else seems to nicely get itself set up properly, so it's really just sliding. So what we should do basically, I guess, is if we're sliding, we should not change our angle. Trying to think of a good way to deal with this. Because we're moving to the left and to the right very quickly. I mean, another thing we could do is be like, well, sliding should have something else happen. I mean, it's indicative of basically we're moving back and forth very quickly with no damping. So let's see, what kind of solutions could we have? See, if you're sliding, that you're... that's just not super great, though. Like, we want sliding to work. You know, as you would expect. So let me think about this case. This is the case where your wanted angle is changing very, very quickly. And I guess what we want to do is your velocity should reset some sort of damping force over time. So like the faster you're running, damping should happen. So let's think. Let's save this level real quick. We've got a good little test area. So let's do our float, rotation, damping. Alright, so rotation damping should basically, we should add the absolute value. So we're like adding to this thing, we're like adding the difference in the angle to the rotation damping, and I guess we multiply it by the delta t. Does it care? Does delta t matter in this case? It's basically what should happen is your angle should change very quickly, and then it should stop. It should tend towards not changing. And if your speed is over a certain amount, we can just clear it. I'm trying to think of kind of a way to do this where it's going to solve it for a lot of cases really nicely. And if we're running over a lot of angle changing terrain, then we don't want to damp the motion. All right. So let's print out the rotation damping. we'll just have it basically, this damping should increase based on all these. It's going to decrease based on, I guess, delta T. So right now this thing is basically going to go from 0 to a gigantic number very quickly. I'm not sure this is really going to solve the issue. Or even if this value can be tuned to solve the issue. Because maybe you can get into this state and then walk a little bit to the right, and then your guy like does a weird correction. So damping's going way up. How come? I hate it when this shit happens where you compile it and it doesn't actually compile. Waste of time. Because I think basically something where it would detect if you could possibly be in this situation would be better than a system that kind of tries to fix it with a band-aid. So it would basically be like cast down to find the angle that you're supposed to be at, and if there is like this massive difference, it should just say, well, you should be standing straight up. And that's pretty much what it should be doing. Instead of trying to use history and all this other stuff to figure it out, it's usually better just to have the correct answer. Just because then you don't have historical blah screwing up your calculations. It might actually not be doing too bad of a job at the moment, actually. Just might not be adding up fast enough. So we need a linear fixed speed. And we need to also set if the linear fixed speed is basically we need to have the damping. Yeah, okay, so float regular speed equals the linear speed minus the rotation damping if regular speed is less than 0, regular speed equals 0, and then we'll do that. So we need this linear speed over here. Alright, let's see if this comes out anywhere close to what we want it to look like. We gotta recompile all the things. So let's see. Do we have a snap? Alright. Because it looks like it's basically doing what I wanted to. Let's go see if there's any little cases where it's doing other things. Oh, it looks fine to me. So damping was too much, is what it looks like. So why are we having trouble when we land? Is that our rotation damping is screwed up? That It's almost correct, but it's not correct. Yeah, why didn't it get fixed there? Why did the damping go up? Like, it was... Hello, Lucas. I'm just trying to figure out what is going on. Setting rotation to 0 while current is 0. Wanted is 0. So like, what ended up happening is our snap was 1 frame. Like our rotation vector was wrong. Alright, Lucas, have a good one. So the issue was that basically what happened was the last frame we were on the ground. We were not on the ground, we were in the air, but our rotation, like our normal, didn't get set. So why don't we just change this to an N32, and we'll just have snap rotation this frame. We'll set it to 0. So if it's greater than 0, snap equals true. Otherwise, we'll minus minus. Alright, so if snap rotation this frame is greater than 0, subtract 1. So basically we'll have 2 frames of snapping once we hit the ground. Just a lot of crazy stuff in order to get our movement code looking proper, which is, well, it's annoying that, you know, you have so much code controlling just movement, just tons of it. But I guess it makes sense. You know, you wish it was simpler. It's like, because we're making a platformer, and you know, we're not making a platformer that's, you know, we have ramps, and we also have a character that's not a frickin' square or a circle or something. It'd be so much easier if a character could just rotate and move and do all this stuff, but nah, we got a biped. We got a dude who can walk around and do stuff, and that just makes problems all around. Nothing is easy. Nothing's ever easy for us. Alright, well, let's put more band-aids on here. So let's see, the wanted angles. So we're going to basically say, like, if rotation damping is 0, let's see, tiny float. Let me see, it's basically like if the last wanted angle, fmap, last wanted angle, fmap absolute value of the last wanted angle minus the current angle is less than tiny float, then equal wanted angles in row should be incremented. Otherwise, the equal wanted angles in row equals 0, and the last wanted angle should be angle. Alright, so that should... We're kind of just shimming this up, and then once we shim it all together, then we can kind of rewrite this code to be higher quality than just garbage like it is right now. So, that's pretty much what we'll be doing. And I'm in a not super great mood today. I'm probably gonna finish up making this work, and then I'm just gonna be done for today, because I don't know, I'm just not feeling it. Just kind of, that's been kind of this whole week, so maybe I need to just chill the hell out, you know? Alright, so I want to make sure our damping works. And that when we like hold that down key, that it fixed our angle. So let's make sure this doesn't just freak the hell out here. So it definitely gives a look of realism to this. To the character, to have him doing these moves. Alright, so what we're going to want to do is clean this code up a bit. And the other thing we want to do is we want to set the max angle that we can actually be at. So we want a U property here, which is going to be public, which is going to be our, I guess, our max angle that will rotate. So float max pitch, max ground rotation. Guess maybe this should be a function. No, let's just have it be a public thing. And let's set it to something reasonable, like maybe 45 degrees. Alright, so if fmath of absolute value of max of angle is greater than max ground rotation, then what we want to do is we want to set angle equals fmath, the sine of angle multiplied by max ground rotation. So we can't, you know, go more than 45 degrees. All right. So let's just unmagic number this thing. Angle damp reset velocity. So let's go ahead and add these two values over here. This is not an int, it's a float. Alright, so it's a float. This will be static const static. Alright, so this is rotation damping plus equals this times, I guess this is rotation damping, G movement, rotation, damping, constant, and that's 10. Alright, So static, const, float, blah. Yeah, let's get rid of that. Gosh, just a lot of stuff. Man. Last normal, angle, all this random craziness. Let's also have a boolean here, which is going to be rotate to match ground. So if rotate to match ground equals false, what we're going to do is we're going to get the flipbook. Let's see, where is the angle? Yeah, we'll get the rotator.pitch. If pitch does not equal 0, then what we're going to do is set it to 0. I guess maybe I should do is greater than tiny float. So we can turn this on and off. It's going to be true by default. Alright. So update rotation does a whole bunch of stuff. We should probably throw it under most of our movement code. Yeah, I think it'll go right in here. Man, what a giant file this thing has become. We're gonna have to split it up at some point.